We're going to start video 4 with a moment of silence for my internet. I did promise you I'd be complaining every single video, and I don't want to let you down. Okay? So here we go. We're going to talk about graphing. And again, sad, can't use Desmos. But I will show you my amazing abilities with a pen. Here we go. To find, this is one of the rare occasions where I'm actually going to tell you how to solve a problem before we actually do it. So to find an equation from a graph, there's two ways. And let's specify equation of a quadratic. That poor Q. That poor Q got broken. There's two ways of doing it. Method 1. Find HK and XY like example 4. Remember in example 4, which was in video 2, in video 2, if you're given a vertex and another point, you can find the equation. So if you're looking at a graph, tell me what the vertex is and find another point on that graph and do the same thing. Or you can use function transformations, just like 3.5. All right. Your choice. Okay. And this goes for the sections, the problems on this homework assignment. This goes for the exam problems from 5.1. This also goes for the exam problems from 3.5. So any time on the exam, which again is this week, is going to ask you about parabolas, you can use this information about axis of symmetry, vertex, maxes and mins, intercepts. Wow. How cool that different sections in math tie in together. All right. Kind of the point, but it's kind of cool anyway. So let's look at some things. All right. Example 7. Write an equation for the following. All right. Part A is going to be the graph of, and this is going to be really hard to show exact points, right? Because I am going to be graphing these by hand. Let's start by going 5. Might have to make it bigger. And it starts at 2, 1. And let's say, all right, it looks like this. It also has the point 3, 3, and 1, 1. And then again, it gets too big. I'll always try to give you very easy to see points. It's a little easier to see. If you look at the homework, that's what you'll see for the exam for something like this. Okay, so let's use the first method, just like example 4. We'll do a little bit more stuff that's more 5.1-y. Okay, if we can find the vertex and another point, then we'll solve it just like example 4. So the vertex here, again, the vertex is the maximum or minimum point. This is the point 2, 1. And we can pick another point. I gave you 2 more clear points here, but there could be more. It could be a bunch. Doesn't matter which one you choose. I usually like smaller numbers, but for these, I think the bigger one actually usually helps. 3, 3, it doesn't really matter. What matters though, is that this point right here is not the same thing as the vertex. Don't want to use the same point twice. It doesn't work very well. You'll see what happens if you do that. You're going to get some 0 = 0 situation, I believe. I think so. I actually don't know what would happen. I think that's what would happen. You can find out. Let me know. All right, so again, f of x, standard form. We use standard form right here. Also, by the way, as soon as we have this, don't need the graph anymore. Anyway, let's look. It's going to be a times x minus h, the x coordinate of the vertex, which is 2, squared plus k, the y coordinate of the vertex. We need to plug in the point and solve for a. So y is 3 and x is 3. Let's subtract 1 from both sides while we're here. We're going to get 2. It's equal to a times, this becomes 1 squared. Oh, 1 squared is 1. A is 2. Great. So our function, our formula, f of x is equal to a, which is 2, times x minus h, we said was also 2, plus k, which is 1. As you come up with an equation for this, by the way, this is true for function transformations as well. I should have mentioned this. We can check our answers by plugging in another point, right? There's also this point right here. 1, 3 should be on the graph, right? 1, 3 is on the graph. We can check our answers this way. If we plug in 1 to the function, we should get 3 out. Let's look. 2 times 1 minus 2 squared plus 1. 2 times negative 1 squared plus 1. That's positive 1, so 2 plus 1. We did get 3 as an output, which is exactly what we expected. This is a good way to check your answers anytime you're doing a problem like this. Again, this goes for function transformations too. We have an equation. Let's make sure that this equation actually has the points on the graph. All right. Do another one, part B, but not over there. Okay. New, fresh, wonderful sheet of paper. Part B, part B. It's going to be this guy. 1, we're going to have a lot of negative numbers. There's a negative 5 right there. I think we're going to have more stuff. So it starts at negative 5, 2. Oops. Negative 5, 2 is right there. And it opens down. We have the point 1, sorry, negative 2, 1. And, right, this is the point 5, 2. This is negative 2, 1. We also have point over here. This parabola is very wide. Right, and whoa, I did this whole graph having the paper completely separate from the camera. Why would you ever need to even look at the problem? I don't know. So, yeah, again, we're just going to use the same strategy. What is the vertex? Well, the vertex is 5, 2. And what's another point? Again, there's 2 choices you can choose here. I usually like the one on the right, I guess. That's point negative 2, 1. So we know f of x is always equal to a times x minus h squared plus k. We know our h and our k here. hk is our vertex, right? This is h, that's k. So it's a times x minus 5 squared plus k, which is 2. Now we need to use this point and solve for a. When x is negative 2, y is positive 1. Here we go. Solve for a. Subtract 2 from both sides. 1 minus 2 is negative 1. A, this becomes negative 7 squared. Negative 1. Wait a minute. Definitely messed something up. Equal to positive 49. Or a is equal to negative 1 over 49. We got our value of a. So either I graphed something wrong, or I made a mistake somewhere else. The vertex should be at negative 5, 2. We have that right here. And then it should go down 1 and right 3, point negative 2. Oh, that's what happens. This is the point negative 5, 2. I labeled it wrong. Hope you weren't crying this whole time, because I can't hear you because I'm recording a video. All right, so h is negative 5. So this is going to become a plus 5. This becomes a plus 5. This becomes a 3 right here. Which becomes a 9. Which becomes negative 1/9. There we go. It almost worked out. Okay. This still makes me a little uncomfortable, because I thought I was going to get a negative 1/3. But, oh, I see what happened. Nope, this is right. Perfect. Great. Sorry about that. So we get f of x is equal to a, which is negative 1/9, times x minus h, which is plus 5, squared, plus k, which is 2. And again, because I'm really freaking myself out over here, let's check our answers. The point negative 8, comma 1 should be on the graph. So if I plug in negative 8 here, hopefully we get positive 1 out. And then I can calm down and I can go to sleep tonight. Not that I'm going to go to sleep right now. But this is making me really nervous. Negative 8 plus 5 squared plus 2. Let's see what this simplifies to. Negative 8 plus 5 is negative 3. Hey, there we go. When we square negative 3, we get positive 9. Negative 1/9 times 9, negative 1. Plus 2 is positive 1. Great. We did it right. Great job, Jason. You can do a Math 1400 problem. All right. So again, this is an excellent opportunity to show how checking your work can make you feel better. All right. Exhibit A, me. Do one more. Okay. Example 8. Last thing in the video. Going to be sketch a graph and find the vertex, the axis of symmetry, and all the intercepts. And again, it's really funny how the book phrases this question because the graph is much easier to sketch if you find these things first. So let's find these things and then sketch the graph. And I'm going to give you a function. All right, the function we have right here is going to be f of x is equal to negative 2x squared plus 5x minus 8. So vertex and axis of symmetry, we can start with that. We can start with the x-intercepts. We could start with a lot of things. Okay. Let's start with the x-intercepts. I'll show you why we're doing that. It doesn't matter which one you start with, but I'll show you why we're doing that soon. So remember, the x-intercepts are when y equals 0. Right? That's when 0 is equal to negative 2x squared plus 5x minus 8. A lot of different ways to solve this equation. You can use the quadratic formula. You could see factors. We need something that multiplied to positive 16 and added to negative 5. I don't know if there is one. Maybe there is. The reason I'm having trouble in my head is we have to divide both sides by a negative before we try to factor. It's very, very hard to factor with a positive here. All right, so, or with a negative there. I'm just going to use the quadratic formula, okay? Because negative b plus or minus square root of b squared minus 4ac all over 2a. Remember, the quadratic formula is just hides. Quadratic formula hides the axis of symmetry right here. Okay. So our zeros are going to be negative 5 plus or minus the square root of 5 squared minus 4 times negative 2 times c, which is negative 8, all over 2 times a, which is negative 2. Simplify this out. Get negative 5 plus or minus the square root is 25. There are really 3 negatives here. We got so many negatives. So minus 3 negatives is still going to be a negative. 4 times 2 is 8. 8 times 8 is 64. Oh, we can stop right here. Right? Because we're not asked. We're not asked to find the zero, when this equation equals 0. We want to know the zeros or the x-intercepts. This is going to be a complex number, right? These are complex. So there's no zeros. All right, there's no x-intercepts here. Okay? So we can find the y-intercept though. That's also something we have to find. Y-intercept is going to be when x is equal to 0. That's going to be y is equal to negative 2 times 0 squared. That's 0. Plus 5 times 0 Well, that's 0. Minus 8. General form is general form. General forms are really nice for y-intercepts. The y-intercept is -8, or 0, -8. As again, I will accept both of these forms, either in the point or this. This is better though. This one right here is a happy face. Right here is kind of a sad face. All right, so we found the intercepts. We need the axis of symmetry, the vertex, and we need to graph it. Okay, so remember the axis of symmetry is -b over 2a. Which is going to be -5 over 2 times -2. -5 over -4, or just 5/4. Remember, the axis of symmetry is x equals that. Our axis of symmetry is x equals 5/4. So there are no x-intercepts. We found the y-intercept. We found the axis of symmetry. The vertex is going to be this, comma, whatever the y value is. We need to find what is f of 5/4. That's going to be the y coordinate of our vertex. The -2 times 5/4 squared plus 5 times 5/4. Oh dear, -8. We plug that into a calculator. I usually use an online calculator, but it looks like, oh great. I do have a calculator on my computer, but not particularly great. -2 times, oh my word. All right, calculator on my computer is garbage. We're just going to do this. Square that becomes 25 over 16. This becomes 25 over 4. We're going to need common denominators. Multiply this out. The 2 cancels. It was an 8. We're going to get -25 over 8. This is 50 over 8. And that's 64 over 8. Let's add these together. -25 plus 25. Sorry, -25 plus 50 is positive 25. 25 minus 64. -39. Yeah. -39 over 8. I believe. That's the y coordinate of our vertex. Our vertex is the x coordinate. It's 5/4 times the y coordinate, which is hopefully this. Getting really nervous with this problem, not having access to a calculator. Especially since the previous example got me all nervous too. All right. But even if there's a small mistake here, the next step will still be the same. We're going to incorporate all of these into a graph. So, get our graph. We have to figure out how big do we want our graph, right? The y-intercept is -8. Axis of symmetry is a little bit over 1. The vertex has a y coordinate of about -5. So we have mostly negative things. All right. So we really don't care about the positive stuff. We care about the negatives here. That's -5 right here. And we know we have to at least go to -8. The y-intercept, is it 0, -8? Let's plot that. 0, -8 is right there. The vertex is at 5/4, -39/8. And you might want that as a decimal for plotting. It's going to be -4.875, I believe. It's almost -5. -4.75, 5/4. That's 1 1/4. 1 1/4 is here. That's our axis of symmetry. And almost -5 is the y coordinate of that vertex. Okay. And then we know it has this shape. It's going to be symmetric on both sides. It's going to go through that point. And again, this is really will also illustrate when I ask you to graph things on your exams, graphing paper is highly recommended, so you don't have to do this. But I'm showing you what it would look like because I'm not requiring graphing paper. So if you don't have graphing paper, you can do this. All right. And again, I don't need it to be perfect. This is definitely not perfect. I just need you to be clear with your points about what this thing does. We included the vertex, we included the axis symmetry, we included the y-intercept. If there were x-intercepts, which there are not, we would have included them too. All right? I'm not going to be really nitpicky about graph. This video was 20 minutes long. Sorry. Hopefully I answered some good questions. All right? If you have more questions, you can always reach out.